All right, so today we're going to talk about how to scale your time series data with Newts and how OpenNMS uses Newts and how the two integrate together. So first, a bit about me. I'm the CTO of the OpenNMS Group, Jesse White. And OpenNMS is the world's first enterprise-grade network management application platform developed under the open source license. So just to break that down a bit, world's first, we were registered on SourceForge in 2000. Our first 1.0 release, or our 1.0 release was in 2002. We're a network management application platform, so we do mainly fault and performance management. Have a series of modules, very extensible platform, and of course, we're open source. So just here's a quick overview of OpenNMS and the different functions it has. First, you'll go ahead and pull in your inventory, right? So tell OpenNMS what it is you want to monitor and manage on your network. And from that, you can go ahead and collect metrics, produce graphs, do thresholding, generate alerts, and then as a result, notifications, email, SMS, generate reports, deal with events. So syslog messages, parse those, and then we have a Grafana UI over top that you can use to, Grafana plugin you can use to communicate with OpenNMS, look at all the metrics, and then you could do some pretty cool things with rules and correlation there. So just, OpenNMS kind of comes with all these tools and allows you to monitor your infrastructure, right? So that said, time series is actually a big part of OpenNMS. And it's been in there in the product or platform since day one. So this is an example of a graph pulled off of one of our demo systems, looking at the traffic on a particular interface on a router at our headquarters in Pittsburgh, North Carolina. So whenever OpenNMS started in 2002, we first used RRDTool as our time series database. Is anyone familiar with RRDTool, or kind of how that works? Yeah, I see a few show of hands there. So RRDTool uses flat files for storage, and based on how many data points you want to store in there, everything is pre-allocated up front. So here's just a quick example on some basic RRDTool usage. First command will go ahead and create an RRDTool file, an RRD file for a data source called speed, and we're going to go ahead and yep, no problem. Better? Cool. Yep. So we create an RRD file for a metric called speed. We're looking to store that data point every 300 seconds. That's the stat specified there. And we're going to store just over 2,000 data points, so a week's worth of 5-minute data points. So that will go ahead and create the file up front. Then the following commands will go ahead and add some data points in there, and then we'll go ahead and fetch some averages. So quick rundown of RRDTool. Also, there's a series of other commands like RRDGraph, for example, that will generate an image from that according to your specifications. So that was our RRDTool. That solution's been around since like 1999. I think the first 1.0 release was. And then in OpenNMS, we've kind of used a different number of time series strategies over the time, right? So when we were first released with the 1.0, we used RRDTool. OpenNMS is written in Java. So we went ahead and talked to librrd via JNI instead of fork execing the RRDTool process every time you needed to write something. And then during that time, there's also an effort to rewrite RRDTool in pure Java. That way you wouldn't have to rely on any system on any binaries or other libraries. Everything would just be in Java. So a few contributors started working on that, and then OpenNMS took up the ownership of that afterwards. And that's still the current default time series solution in OpenNMS today, just because it kind of works out of the box, right? And then, a few years ago, we started working on JRRD2. So originally, RRDTool was strictly single-threaded, right? They relied on some particular calls, I think the getopt, that would only allow a single you to write to any given file at once. So we went ahead and improved that and implemented JRD2. And at the same time, we also started looking into Newts, right? So the main problem we had at RRDTool was dealing with I/O and being able to scale that. So as customers want to monitor more and more metrics, we have the problem of, provisioning more and more I/O to the OpenNMS system. And fortunately, there's solutions like SANS and the like that allow you to scale that out, but that's still very limited. So we started looking at developing an alternative solution, and this was back in 2013. Similar to the last presentation, in a time series database space, there wasn't much at that time aside from OpenTSDB, and HBase is not something we want to look at, so we developed our own on top of Apache Cassandra. So that brings us to Newts, right? So Newts is a time series storage strategy or database based on Apache Cassandra. Few main features. It's designed for high throughput, right? So leveraging Cassandra's linear scalability and write performance. Also designed for grouped access. So a lot of times we find ourselves going to graph and retrieve combinations of metrics at the same time. So the idea is to store those on the same Cassandra node so that they can be retrieved efficiently. So think when we're looking at like if in octets, if out octets, like on that first graph I showed, those are commonly displayed together. So we'll group them together on the same node. And the last is late aggregation. So what we end up doing is storing all the raw data points in, and when it comes time to query them based on the number of data points we want to display, we aggregate those based on averages, min, max, et cetera, whatever consolidation function you define. So again, each time series strategy has kind of their own definitions or what they call the various terms. So Newts is centric around the resource. So at first we have a resource, which is just a string or a key. And a resource is used to group a series of related metrics, right? And then we use the term samples to denote a particular value of a metric at some point in time, right? So resources, metrics, and samples are the important bits there. So just for an example, here's a particular graph. We're looking, this particular data here is collected from OpenNMS via JMX against its own JVM, and the resource ID here is one OpenNMS JVM, and then that's the name of the MBean. So basically a unique ID describing that resource, and then that resource has a number of metrics, right? Each percentile here would be a particular metric, and then there'd be a number of samples associated with those. So we can look at kind of the schema and how things are stored in Newts, right? So I did mention samples. So this is the primary primary table where everything is stored. So the most important part here would be the primary key, in particular that first part, right? So that defines the partition key and defines where the data is stored in Cassandra. So at first we have this context field, which is just a text argument or some string, and that allows you to have kind of different tenants. So if you have different or multiple applications using the same resource name, you can kind of go ahead and use them, put them in different contexts instead of creating different key spaces, right? So that acts kind of as like a tenant ID, if you will. Then finally, we have the partition. So that's numeric number, or that's a number related to the timestamp that helps group metrics in the same time period. So by default, we use 7 days. So that partition key there will make sure that all the samples for a particular resource over the last 7 days are grouped together on the same Cassandra node, right? And then we have the resource, right? So that's it for samples. And as I did mention earlier, we do late aggregation. So just a quick overview of that. Whenever you go ahead and generate a graph, and let's say you're looking at a year's worth of data, you don't want to go ahead and pull all those data points into your 1,000 pixel graph, right? So you want a way to kind of aggregate those. So the way Newts does that is very similar to the way that RRDTool did it. So the process will go ahead and gather all the samples for the block of time you're interested in, and then we'll break that off into different time slices based on how many data points you want. Then we'll generate a series of primary data points using kind of weighted averages of the different samples. And finally, it'll consolidate those using the consolidation function that you described. So probably average in most cases. So main point here is just that we end up doing weighted averages of all the data points over the time period, try to summarize that into the graph. Yep, go ahead. This happens always at query time. Right, yeah. So in order to make the right pipeline most efficient, we do this strictly at query time. Yep. Yep. No, we just recalculate that every time. And those queries, even for weeks or months, it ends up taking about a couple hundred milliseconds or so to process, which hasn't been a problem when looking at a graph or so. Another thing we do in Newts is we allow you to search for the different resources and kind of figure out what you have. So we do that by indexing the resources in a table we call terms. So again, the partition key here is the context, as I described earlier, a key value pair, and by searching that, by looking that up, you'll be able to get the list of resources that have those key value pairs. So here's an example of a search query. So Newts supports some subset of the Lucene query syntax. So for example here, what we can go ahead and do is pull out the list of resources that are tagged with Data Center 1 or Data Center 2 and are in the UAT environment. So on the back end, what this will end up doing is actually performing 3 queries against Cassandra, right? One selecting all the resources in Data Center 1, one selecting all the resources in Data Center 2, performing a union over those 2 sets, right? And then selecting all the resources in and UAT, and then an intersection of both of those, right? So there's room for optimization there, but that's how it works currently. So that's kind of whirlwind overview of Newts and the different tables, how things are stored there. So now we're going to go to how that all works with OpenNMS. So OpenNMS has a number of collectors. So we're able to go ahead and fetch metrics from different endpoints via HTTP, JMX, SNMP, you name it, there's a bunch of them. And those different collectors end up generating what we call a collection set. So that's a data structure that's specific to OpenNMS. And then, after that, we look to convert that to the samples, as we described in the Newts API. So that takes part in the Java process. So once we have those samples, we publish those to a ring buffer. So that's pre-allocated space in memory in the JVM. And then we have a series of threads that end up pulling the samples off the ring buffer based on whatever batch size you have configured, and then directly inserts those into Cassandra. So in this case, Newts is simply a Java library loaded in the OpenNMS JVM. It's also possible to deploy Newts as a standalone application and then use REST to interact with it, but we choose to embed it here. So the samples are then added to the samples table, and the terms inserted in terms, and you see there's an extra cache there because once the resources are indexed, we don't need to go ahead and index them again. So that does have some kind of problems though. So whenever OpenNMS starts up on a cold boot, it's going to end up doing a lot more writes to the tables than it would once the cache is hot, right? Because we don't know what we've indexed yet. So we go ahead and reinsert all the metrics, right? So it takes some time for it to warm up and prime that cache. There's different ways to work around it, of course, but that's how we have it there today. And then we also have different ways of graphing the metrics stored in Newts, right? So as I mentioned before, we're coming from an RRD world, right? So RRDTool comes with a command line tool called RRDgraph, and it has its own syntax for representing these graphs. And in OpenNMS, there are already like hundreds and thousands of these kind of pre-baked graph definitions. So we needed a way to make that work with Newts. So we went ahead and developed a library that we call Backshift that goes ahead and reads that same RRDTool syntax and generates the appropriate queries to the Newts APIs and renders a similar graph here. So on the right, you'll see the graph generated by RRDgraph. And on the left, you'll see by Backshift using that same graph definition. So look pretty similar. So now, in terms of scaling out, while preparing for this talk, I looked at the presentation before me. I was talking about inserting 1 million metrics into Kairos DB. So I saw, hey, what would it take to do 1 million metrics in Newts, right? So I spun up a lab on AWS. And in the end, I was able to do just over 1 million samples per second on a 5 Cassandra instances on some I2 4x larges. So that's 5 instances. Each one of those has 4 SSDs in them. So I bundled them all up in a RAID 0 array formatted with XFS, built a Cassandra cluster out of that, and then used 3 instances to generate load. And that's what I got. So on the right here, you see a picture of Nmon, just a snapshot of one of the Cassandra systems during the load test. You see all the CPU threads are just fully used, and we have a bit of I/O there at the bottom as well. And incoming through the ETH0 interface, we have about 35,000 kilobytes of traffic. So, yeah. So basically, since we leverage Cassandra, you can just scale out, add as many nodes as you need, and you'll be able to get the performance there. So that said, the transition from RRDTool to Cassandra-based solution hasn't been that easy either. There's been its challenges. So one of the things we face a lot is how to estimate the amount of disk space usage. In RRDTool, it's kind of straightforward. You pre-allocate the RAs, and you know exactly how much space it'll take. In Cassandra, that's a bit more gray, right, depending on compaction and kind of how all that works out. So that's still something that we're trying to sort through. We have some numbers to be able to estimate, but they're not always quite exact. And also, depending on the compaction strategy that you use, you also need to overcommit disk space, right, to be able to handle compaction properly. Also, people aren't really used to managing Cassandra clusters, right? So, having to repair it every so often, that's not something that everyone knows about yet. And another one is data mangling, right? So people, find different reasons that they want to rename particular series or go ahead and delete specific data points. When we used our RRDTool, everything was flat on the file system, right? So you could just go ahead and remove a file, move it in a different directory, and everything would appear. But now that we're in NoSQL world, it's kind of harder to go and do that mangling. So we find ourselves having to provide tools to kind of get that same functionality that people were used to. So that was my whirlwind tour of Newts. You can check us out at newts.io. There's a wiki there with all the details on how to get started, along with links to the GitHub repositories, etc. So we do have some time for questions. If there's anything about Cassandra, Newts, OpenNMS, how all that works together. Yep, over there. Yeah, sure. Yep. So as part of our consulting and support services, we do end up helping our users get started. But a lot of that's just training and educating them about how to do things right. Yeah. Anything else? Yep. Sure, right. So one thing that came recently was actually a customer wanted to delete a particular data point, right? So said, I don't, this was off. I didn't collect it properly. I want to go ahead and delete that, right? So now in RRDTool, there's tools there to kind of export your RRD file to sort of XML-based structure. Then you can edit it and then re-import it back and dump it, right? And then that data point is essentially gone. And then they're trying to see, how can I do that in Cassandra world there now? So if I go back to the samples table here, how would you go ahead and delete a particular metric from this, right? It's a little trickier. What you have to do is determine what the actual value of the partition key is, which you then have to do some math based on a timestamp and kind of isolate that. So it's possible, it's doable, but it's just a little trickier. So that's where we find ourselves having the right tools and help the users out in determining those.
So essentially, you will have to do a backfill of some period of time of history.
Yeah.
You will have to set that.
So Newts, you can actually insert, because we do late aggregation, so we aggregate the data point whenever we query it, it's actually very easy to backfill. So,
you're saying that the backfill can be a different segment?
Yes. Yeah, so backfill would just be, it'd just be like inserting live data. It'd be the same time, just alter the timestamp, it'll go in the right space, right spot, and when you go ahead and query it, it'll aggregate it all properly. So that's something that you couldn't do with RRDTool beforehand. Yeah. Yep.
When you're getting the samples,
Yep.
is there any way of using the
So you can go ahead and get the raw samples if you like. So if you want to go ahead and get the raw data points, there's APIs for that. And then if you want to change the way things are aggregated, there's different flags and things that you could tune on how to do that. So yeah, it is possible. Cool. Still got a minute or so. Anything else?
Can you do a little bit more introduction about the OpenNMS? I believe it's more than just considered.
Oh yeah, OpenNMS is quite, there's a lot of breadth to it. So just quickly, OpenNMS, maybe I could just show you an instance. We do still have a few minutes left here. So let's see. Let's just set up mirroring. All right, cool. So here's an instance of OpenNMS right now. And then you see on the left there is just a bunch of alerts and alarms and different problems that have been detected. So the fundamentals is we have this thing called provisioning requisitions. So you need a way of telling OpenNMS what all your inventory is and what it is you want to monitor. So the way you get that stuff into OpenNMS, there's two means, but you can either go ahead and discover it, or you can tell OpenNMS specifically, here's what I want to monitor. So you do that via provisioning requisitions. Here's an example one here. Bunch of nodes. Here are their names. Here where they are. Here's their IP addresses. And then they'll be pulled into OpenNMS. And whenever they're inventoried, OpenNMS will go ahead and run a series of detectors on them to try to figure out what services are there and start monitoring those automatically. So here's a particular node here. You see it has a few IP addresses. We're monitoring a number of services on those. So if any, and these are pulled, every 5 minutes or so by default. So if a problem is detected, we'll go ahead and raise an alarm. Then there's different ways to kind of take that alarm and generate notifications or different workflows. Also, there are cases where you want to take multiple alarms and do business logic over top of that. So if that's down and that's down and that's down, that means I have a problem there. So we have all the workflow and tools to do that. And then we do data collection, as I mentioned about. So that would be the time series piece. So you can go ahead and do the resource graphs from the collected metrics on these hosts. And here's kind of an example here. And from those, you can do thresholding, right? If the CPU goes above this threshold for this amount of time, then send me an alert, generate an alarm, et cetera, et cetera. So that's OpenNMS in a very brief way, but you kind of get the idea. Anything you want to do with respect to fault and performance management, chances are it's already there. Yep. Yeah, so OpenNMS is completely open source, published under the AGPL license. There are two distributions of it. There's Horizon, which is kind of our upstream version, similar to Fedora for Red Hat. And then we have our enterprise version, which is called Meridian, available under a paid subscription, but it's open source nonetheless. And that's our more stable version that kind of lags a bit in feature set. And we have long-term support for it, et cetera. Yeah, so the solution right now needs to be run on-premise. We don't have a SaaS-based offering yet. That is something we're actively looking into, though, because there are some challenges with administrating and maintaining OpenNMS. So as part of our way there, we've added technology that we call Minion. So traditionally, OpenNMS had to talk to all the devices itself, right? So from the OpenNMS system, it was the one responsible for all the polling and data collection and going out there and making sure that things were running as they should. Since then, we've added Minion, which allows OpenNMS to extend its range and kind of reach behind firewalls and that. So the Minion will actually can be deployed at a remote site. it's going to talk to the devices and then relay the information back to OpenNMS. Yeah, so current OpenNMS for data collection, strictly a pull model. For service availability, we support both actually. So you can do either pull, or we can determine service availability based on incoming event streams. So essentially a push-based model. All right, I think we're out of time and covered all the Newts. Thanks, guys. Thanks for listening.